but thanks for the reminder. Okay, so let's go back again. So today we will talk about the applications of steady-state control volume. All right. So in engineering, we encounter multiple devices with different objectives to achieve different objectives of these devices. And what we want to do today is we look at these devices and then we try to apply this energy balance for a control volume at steady state. Okay, and when you look at each device, we will see what's the objective of this device, and based on the objective, we will maybe apply certain approximations or assumptions. Okay, to neglect some of the terms that maybe are not important. So the device of interest in engineering that we will look at today is the nozzles and diffusers, turbines, compressors and pumps, heat exchangers, and throttling devices. Okay, so each one has, you can think of it as a category of engineering device. So let us start with the nozzles and diffusers. Okay, so what is a nozzle and what is a diffuser? As you can see here يا شباب في الفيجر هنا. So a nozzle is basically is a device is the device with the objective of increasing the velocity at the exit. Okay, so you have, let's say, mass flow rate during this. Let's say you have a mass flow rate in a pipe, and then at certain location in the pipe you want to increase the velocity of this flow so high that you are. What do you do in order to achieve this, ya shabab? So the nozzle, what the nozzle does is it reduces the cross-sectional area in the direction of the flow. Okay, so it reduces the cross-sectional area in the direction of the flow. So how does this increase the velocity? Okay, if you think about it, how does reducing this flow cross-sectional area increases the velocity? So you can think of it like this. Like when you have a flow, let's say you have a flow in a pipe, okay, and suddenly you decided to block this flow. تخيل انك ايش؟ You put your hand, or what do you feel in your hand when you put your hand here? ها شباب, let's say you have a flow and then you block the flow. What do you feel in your hand?
Pressure.
ضغط يجيني.
Okay, so you feel pressure. That means the pressure, what happened to the pressure here? It build up and start putting. So when you block the flow, you accumulate high pressure in the location here. Okay, so now imagine that you start opening your fingers slowly and open just small space in your fingers. What happened to the flow here now? It will jump. What happens is this high pressure start pushing the flow, and from the small area the velocity started increasing highly. So it's like the high pressure is pushing the fluid at a high velocity at the exit here, after your fingers, at the exit. And this is exactly what does the nozzle do. So basically this decrease in cross-sectional area causes the pressure to build up at the inlet here, which pushes the fluid at the exit at a low pressure. So the velocity at the exit is higher than the velocity at the inlet, and the area and pressure at the exit is smaller than the area and pressure at the inlet. Okay, so this is the objective of the nozzle. The diffuser is exactly the opposite. It's just exact opposite. The objective of a diffuser is basically to reduce the velocity. Okay, so we want, let's say I have high velocity fluid and I want to reduce this velocity, so I can use a diffuser that will result in increasing the surface area in the direction of flow, which reduces the velocity here at the exit by increasing the surface area. And also the pressure at the exit will also increase. Okay, So this is basically what's a diffuser and what's a nozzle. Any question? Is it clear? So what can we neglect يا شباب in a diffuser? So now I want to apply this energy balance between the inlet and exit. So what can I neglect for a diffuser and nozzle and diffuser? What do you think? Is there any work? شباب. So if you see, you can see that I'm not doing any work in the system. There's no boundary, there is no rotating shaft, there is nothing. So I can neglect the work here. What about the kinetic? Can I neglect kinetic energy? Huh? Can I neglect kinetic energy? شباب, forget about the quiz for now. Please focus with me.
No, we can't.
معك يا دكتور بس ما عندي جواب.
الكينيتيك انرجي وش هي؟
Yes.
half mv square.
So let's go back to the equation. What do we see here? What's the general equation? Let's go to this one here. I have one inlet, one exit. Okay? So h1 minus h2, v1 squared minus v2 squared over 2. Can I neglect the kinetic for a diffuser?
No.
No, because the objective is to increase the velocity, so the difference is actually high in this case. So we're not gonna neglect the kinetic energy. What about potential? I can say the elevation is not much different, so I can neglect. So basically for a diffuser, we can neglect the work, potential energy, and also the heat transfer. Okay? An example of this nozzle, by the way, is at home يا شباب. أتوقع يعني كلكم ممكن أو الأغلب يعني غسلتم حوش. اوكي. طيب اذا بغيت تزود سرعه المويه في الخرطوم شو اسمه حق المويه في الهوز, what do you do؟
حط صبعك.
اضغط
تحط
عليها.
اصبعك. وش يسوي لما تحط اصبعك؟ وش الفكره؟
يصير يطلع اقوى بشكل اقوى يعني.
اصغر الاريا واخلي
بالضبط. So when you put your finger, you reduce the surface area and you build pressure before your fingers that will push the velocity at the exit, the fluid to be higher velocity at the exit. Okay.
دكتور
Yes.
الحين حنا يوم صغرنا الاريا الماس اللي صار يطلع يمكن يعني مو نفسه فالكينيتيك يعني عارف.
لا شوي يعني think slowly. انت دخلت الحين الماس في الانرجي في what's your question exactly؟
الان انه الماس ممكن يختلف, ماني عارف اذا هو يختلف ولا لا.
ليش يختلف؟ الحين الماس فلوريت وشو؟ الماس فلوريت is rho VA is a multiplication.
اي بس الاي يختلف.
لا احنا وش قلنا؟ m.1 equal m.2 ما يفرق. الاريا بتتغير لكن بسبب بتتغير الفيلوسيتي. فلو افترضنا ان الدنسيتي the same temperature both في A1 V1 equal A2 V2, صح انه الفيلوسيتي تغيرت لكن الاريا تغيرت برضه, فبالتالي الماس فلو ريت الام دوت ثابت. So that how much mass per unit time is constant in this case. Of course we're talking about steady state. Okay. لكن انا اتكلم هنا اتكلم على velocity, just the increase in velocity. All right. So this is just the application of this nozzle at home. يعني. In applications in engineering يعني, where we need high velocities, very high velocities, the difference can be very high. All right. So after we do this neglecting these terms, we end up with this energy balance where h1 minus h2 plus v1 squared minus v2 squared over 2 equals to 0, where this is a steady state control volume. Okay. This is the mass flow rate here. So I'll try to go faster because I need to go through this before the quiz, before I stop for the quiz. So the second device is called turbine. Okay, and the turbine يا شباب basically is a device used to rotate a shaft. So I use some gas, fluid or liquid or whatever. I let it enter here, and then it will push some blades here. You can see inside. So the gas is the system, does work on this shaft, okay, or these blades, and then the shaft will rotate and generate power. Okay, so there is power output. So the objective of this turbine is to generate power. That means work is important here. I cannot neglect work. Usually heat transfer outside of the turbine can be neglected, as well as potential and kinetic energy. So if we do this, we end up with this equation where the work here, after neglecting heat transfer and kinetic and potential, so the output work is simply m dot h1 minus h2. Okay, and since this is work output ya shabab, that means the system is doing work on the shaft. So this is work done by the system, right? So it is, انتم عارفين الconvention صح? Work done by the system is positive and work done on the system is negative. So when you do the calculation, this output power should be positive. Okay? Or if you are required to find m dot, for example, and I give you the value of the output power, you should put it as positive. Okay? So this is regarding the turbine. If you have any questions, please stop me, okay? At any point. So this is regarding the turbines. Again, the turbine is used to generate power, so I have power output. If I do this neglecting potential, kinetic, and heat transfer, I can get this final form of the equation. The third device we're going to talk about here is the compressors and pumps. So what is a compressor and what is a pump? So these devices, the compressor and pumps, are used to elevate the pressure. يعني أنا عندي fluid, I want to increase the pressure of this fluid. Okay? If my fluid is gas, I call the device compressor. If the fluid is liquid, I call the device a pump. That's the difference. So when you hear compressor, that means it's a device to increase or elevate the pressure of a gas. If you hear the word pump, it's a device that is used to elevate the pressure of a liquid. Okay, so that's the main difference here. طيب, how do you elevate the pressure? By applying input work or input power. Okay, so you have a shaft maybe, or you have blades, shafts and blades, but this time I use electrical power to move this shaft in order to push the fluid. Okay, so basically I'm doing work on the system or on the gas or on the liquid, on the substance. Okay, so if we apply similar balance as the turbine here, we're going to neglect potential energy, kinetic energy, and heat transfer. We're going to end up exactly with the same equation for the energy balance. However, the difference here يا شباب إنه my power here is input power. So if you need to use it in the equation, you need to put it as a negative. Or when you do the calculation, you should expect the power input to be a negative sign. Okay, so this is regarding the compressors and pumps. واضح? So again, compressors and pumps are used to increase the pressure of a gas or liquid. If it's a gas, it's a compressor. If it's a liquid, it's pump. And then we can neglect potential energy, kinetic energy, and heat transfer, and so simplify the energy balance into this form. The fourth device here, Shabab, that we're gonna talk about is what I call heat exchanger. Okay, heat exchangers. So the heat exchangers basically, Shabab, they are devices used to exchange heat. But I gave you an example for it before, which is the feed water heater. You can see in the feed water heater, I'm having, let's say, 2 inlets here and 1 exit, and for each inlet I enter different, maybe the same substance but different states. So they mix together, they exchange heat, and they come out at a third state. Another example of a heat exchanger is what we call counterflow heat exchanger. In the counterflow heat exchanger, I have one large pipe and another small pipe in the middle, inside this large pipe. So what happens is in the small pipe I put مثلا cold fluid, and in the bigger pipe outside I have hot fluid. So the hot fluid is moving and it is exchanging heat with the cold fluid. So heat transfer will go from the hot to the cold fluid. Why do I call it counterflow? Because the flow of the hot fluid is opposite to the flow of the cold. So you see the hot going, let's say for example, to the right, the cold going to the left. If both of them are in the same direction, let's say the cold is also going to the right, this is called parallel flow heat exchanger. You will study this later in the heat transfer course, inshallah. It will be in more details. All right. So this is some of the example for heat exchangers. Now, if I want to apply the energy balance on a heat exchanger, so I need to look at the different things. For example, is kinetic energy important here? Maybe not. Okay, so kinetic energy might not be important, same as potential energy, as well as we can neglect work. Okay, so because I don't have anything moving, I'm not moving any boundary, or there is no mechanical effect here, it's just flow exchanging heat. So basically, if I apply the energy balance, and remember, for the heat exchanger, I might have multiple inlets and multiple exits. So it's not only one inlet, one exit. Okay? Tamam, shabab? So I don't have one inlet, one exit. I could have multiple inlets, multiple exits. In this case, when I apply the energy balance, I will include the summation over the inlet, m dot inlet, h inlet, minus summation over the exit, m dot exit, h exit. Okay? This is after neglecting kinetic, potential energy, and work. Questions?
دكتور
Yes.
وش البوتنشال انرجي؟
GZH أو Z. وش البوتنشال انرجي؟
اي هو وش قانونها؟ توني بس خلاص فهمت.
دقيقة ترى ما سمعت آخر شيء، وش قلت؟ آخر شيء؟
لا خلاص فهمت. نسيت القانون حقه بس.
This is physics يعني you have studied this. Okay. The last device يا شباب we have here is the throttling device. A throttling device يا شباب, the objective of this throttling device is to cause significant reduction in pressure by restricting the flow. Okay? You can see that the physics here is similar, يعني similar to the nozzle, for example. I am basically reducing the surface area here in order, but the objective of this device is different. Okay? Even though I have large area at the inlet and small area at the exit, the objective before was to increase the velocity. The objective now here in the throttling device is to reduce the pressure. So it's significantly reducing the pressure by significantly reducing the surface area here. But the R device is mainly used to cause significant reduction in pressure by restricting the flow. Okay? So for idealized throttling process, ايش يعني idealized؟ and for ideal throttling device, the kinetic energy, the potential energy, heat transfer, and work are all neglected. Okay? So I can neglect the kinetic and potential as well as heat transfer and work done. Alright? ليش قلنا idealized؟ لأنه this is the ideal case where all of these are neglected, are assumed negligible. Maybe some cases, maybe it's important, maybe the kinetic energy is important, maybe we should include the velocity, For other cases, maybe there is heat transfer. Okay, like I'm telling you here, I'm giving you the ideal case or the ideal process in this case. Okay?
دكتور
Yes.
هنا برضو الفلويد يصير أسرع.
صحيح، يعني الفلويد هنا ممكن يكون أسرع، لكن ممكن أيضا زي ما قلت لك أنت if you block it completely there is no velocity at all, right? So the idea هنا في throttling device is to reduce the pressure so much that you almost يعني block the flow. Okay? The velocity difference might not be significant. So that's why we can neglect kinetic energy here. But yes, theoretically speaking, yes, the velocity at exit is higher than the velocity at the end. But when we compare terms, when you compare the kinetic energy term with other terms, it might not be significant. All right? So if you apply the energy balance, neglecting all of these terms, you end up with H1 equals to H2. Okay? And also remember that pressure at the exit is much lower than the pressure at the end. That's the objective of the device. Okay? So this is the result of the energy balance where the enthalpy at the inlet is basically the same as the enthalpy at the exit. The last point I wanted to mention here is in many of the applications, ya shabab, 2 or more devices are combined together to achieve certain objective. Yani not only one device is used in the application. I could have multiple devices, 2 or more, are used in a combined system so that they achieve certain objectives. This is called what? This is called system integration. An example for this, ya shabab, is a power plant. In a power plant, I generate electricity by using what? By using a turbine, okay? I use a turbine that rotates a shaft that is connected to a motor that will generate electricity eventually. And I have a gas going here, let's say water, steam turbine. I have steam going inside, then coming outside. Maybe I have a compressor, then I have a condenser here, then I have a pump, maybe. Then I have another heat exchanger. So this is heat exchanger. This is another heat exchanger, let's say steam generator that change the liquid into a gas, then bring it back into the turbine. Okay, so this is called system integration. I'm integrating multiple devices, more than 2 devices, 2 or more, together to achieve a certain objective. Okay, so this is just for your information. And any of these devices here, if I take each single device in this system, I can apply this energy balance. So I can apply energy balance to this turbine, I can apply energy balance on this pump, and so on. Okay? So you can apply the energy balance at each specific device separately. All right? That's all what I want to talk today. The quiz will start in a couple of minutes, but any quick questions? طيب شباب, please click on the link. Please, I send you the link also in the chat. Please click on the link for the Zoom meeting. I started the meeting now. Okay? So I will switch off the Teams and then we can start the Zoom. Okay? يلا شباب.